Hello all. Thanks for the quick intro. And today, what I'm going to talk about is, building a reliable systems. And as a engineers, as architects, we used to build this, resilient systems where we have all these retries, failure mode analysis, all those things. But at the same time, what I'm going to talk about is how can we build a reliable system in this agentic world, right? So, we are in the era where we are using all these agentic tools like Cursor, Cloud Code, and all those changes, and we are also generating lots and lots of code, and we are also generating lots and lots of features and new codes as well. At the same time, what we are also seeing is lots and lots of issues and incidents which is happening across the industry, and that is one of the major reasons is today the agents doesn't have the full context as the humans we have. Second is they're limited. They sometimes assume some context that hey, this is how your system is working end to end, and they make those changes, and that is the reason like we are also seeing lots and lots of issues today. Second is previously we used to as a customer or as a user, what we might usually do is we go to a software and then we used to do those operations. But now all these agents are doing the operation for us. So previously what we used to do is we'll have some manual checking that whether my software is working as based on the specific forms. But today your agents are interacting with your systems and they are not following the exact pattern what you are expecting from your forms, right? So now the the need of the hour is we need to make sure that our system is working in a single unit, not just based on a single flow. So that is the reason, like out of lots and lots of we as engineers we have this test cases, UI test cases. Still, there are bugs which are being missed and then which is going to the customers, right? So that is a problem statement which you have seen, which we are seeing, right? So that is a problem statement which we as a systems or we as a engineers which we are seeing daily. The major gaps today is in a distributed system there might be lots and lots of teams who is operating your single user action. And also like teams are building the tests specifically to their specific scrums or specific features or specific service, and they are only creating a test case or any validation specific to their system. Second is whatever the frameworks which we have today is mostly synchronous testing frameworks, right? Where they just make sure that verify, hey, like I'll try to create a order whether the order is created or not, right? Specific to a single synchronous based approaches. Second is the last one is the works on my service, right? So today we would have seen this problem statement called like work on my machine. Similarly, there is this problem called work on my services, right? So in a production system, we might have multiple services, and you might be deploying it to E2E. Everything is working as expected, but once you deploy it to prod, there might be a different configuration or different feature like which is there in the another system, and your your flow or your user flow might be having an issues, right? So these are the pretty much standard issues which we are seeing. Let's take an example of a like rough architectural diagram. In a distributed system like Intuit, right? Intuit is a company where we build a lot of softwares where companies run their business in Intuit, which is like QuickBooks or TurboTax and all, right? So companies use their like run their business in the QuickBooks. Let's take an example like where a order management service today, whenever a makes an order, orders management service accept that order, and there might be another service called inventory. So based on the order management event, they'll reserve or they'll update the status of the inventory, and there might be notification system, there might be payment system, and there might be multiple system which is working in the orchestrated way for a simple user action, right? So this is a pretty much standard. But having a single system which is not working, maybe a reports or any critical system, that might impact your customer day-to-day work, right? So we cannot have a time where customers are relying on us for their day-to-day operations. So to solve this, in Intuit, couple of engineers who has a separate scrum, separate responsibility, we met together and then see like this is a common problem which how are we going to solve. So that's why we built this platform called Neodime. So this is a place we built how can multiple teams can onboard their validations in this platform so that we can verify the end-to-end user scenarios, not just a simple system or individual systems. Today, almost like 1034 test suits are running daily, and almost like 138K tests are running weekly. So when we build this, we had some core features to be part of it. I'll take like a minute on each of the things. First is the async and consistency-based use cases, right? So basically, as I talked about order management service, so whenever we do a order, right? So order management will accept it. They'll create an event, and eventually even inventory services will listen to it, and then they'll update the quantities, right? So when you try to query the inventory management right away, then the data won't be right away available, right? Which is eventually consistency. But if you try to verify that with your like existing frameworks, it might fail and it might flaky. That is why we should have a first class support on the eventual consistency. Second is resumable execution. Into it, like we have some area where we have long running jobs which takes lots of like multiple hours, that we can import some data from our external systems or some banking data or something. So that how can we make sure that we trigger that action and then we can verify those data are imported as well. Third is native eventing frameworks, right? So today in the distributed world, all these Kafka, SQS, and Pulsar, all these are like pretty much a standard components in your distributed end-to-end systems, right? So how are we going to make sure that teams can use that tools as well, so that they can produce an event, they can validate the events by consuming those events, and contract testing. So another point is the contract testing is like how as a engineer, right? How can we make sure that my upstream is providing the same contract and I am not breaking my downstream, so that each teams build their contract test so that they are not breaking any upstreams or downstreams. It's not just an API contract, but both as a domain event or APIs as well. The last part is the agentic part. So today, all our entire SDLC has been changed, right? Like we used to build software our own, but today agents are building for us. Similarly, how can we leverage AI so that they can build their validations using agent is the first class features which we built, so that the teams can build. I'll take a minute to talk about what are the things which we try to incorporate within our platformers. Teams can provide their framework scenarios that, hey, like as a user, this is the scenario, so that they'll explain the scenarios in a plain English, and then agent will look at your context which is there in your repos and other areas, and then able to test out those scenarios, and then they'll able to create a PR for you. And whenever there's a change, they should be able to confirm the changes, and then if there is an intentional change, they'll try to fix the change and then automatically create a PR for your test cases, right? So this is mostly like a phase where agents is working for you, so that the teams can focus on the features and agents can work, and then they can build your like test areas or the validations. So these are the areas which we built. I'll try to go to demo part which we built, so that at least I can discuss in detail here. Yeah. So I'll just share you. So I have a local demo service which I have locally set up. So this is like I have a simple Python like demo service which I have set up, which is one is inventory service, second is the order service. So this is the scenario which I talked about. One is the order service which accepts the order, and the inventory service which reacts to the orders, right? So this is a local service which is up and running, and both order service and inventory service are like interacting through Kafka or the domain events, and so this is the services in your like real time. So I'll try to simulate the idea into a local way, so that at least I can demo it here. So this is like a pretty much standard test case where we build the test case in a BDD style, that hey, what is your scenario, like what is, so basically this is not your verifying your logic or verifying your code. This is verifying your user action, like as a customer what you are doing it, right? Like which is, as a customer I'm placing an order, right? So what is that action, and what are the given criteria which you have, and what is the condition when customer does it, what is the scenario, and like we'll also verify end-to-end systems, right? It's not verifying your order service. At the same time, you have to make sure that all the impacted areas for that user action has to be verified, starting from order service. Then you have to see whether the domain events are in the right contract, and then you have to make sure that other event is also consuming it and then updating it, so that you can verify end-to-end. So this is the pretty much the test structure. I'll take a minute to describe like what is the difference between a traditional test cases versus this is. In a traditional test case, what we used to do is we'll run this, right? So that what we'll do is PyTest or any JUnit frameworks or any Karate or any frameworks, what it does is it runs within your like local or any container, right? So that is the normal process. But what we do here is we consider, like we don't do directly in your local. I'll try to show it here, but what we do is we consider them as a distributed workflow, where we start the test and then we try to execute them by step. So after every step, we try to capture the data and then save it. Consider a case like you have a step that I want to pass for a minute or pass for an hour. So what we do is we or we pass the entire test, so that we'll have a pass there. And then once that 1 hour is completed, what we'll do is we'll resume the entire test and then run from there, so that at least consider a case for a distributed system, you'll have SLAs, right? So that when your data should be available, right? So you can have some passes within your systems. All these tests are also retriable, so that you can make sure that your eventual consistency tests are ran. So I'll try to run this against my local, just to show here. So when I try to run this test, so basically consider this running in your in your platform, so that whenever Teams has scheduled it and it is running, so that they run all this in your platform as a distributed, like a kind of a workflow, and they succeed, and then all these test metrics are captured by our platform, and we'll show the details that, hey, what is your step is working, like where starting from given when and then and all, so that whenever there is a consider a case like a domain event structure has been changed, or our inventory system made a inventory system made a change, so that if that is failing, you can know that which section is failing, so that you can make an action and then do it, right? So this is the first part, where as a team I can go and then build the tools, or build the test case or validations, and then I can cover the user actions, not just your logic or your code. So this is the platform which we built. That's what I got to share. Second item is the agentic part, which I want to cover is consider a case like, as a team, there was an intentional change which we did, so that the requirement has changed, that I have to make sure that I have to reserve some stocks. So there was an intentional change, you deploy to E2E. What happens, like there's a intentional change, your test will start to fail, right? So that's the expectation. So when I run the test, let me deploy these changes. So I'll just rebuild this change. Let me stop the current, so that at least I'll have the changes up and running. Yeah, I think it stopped now. Let me restart the application. The latest change, which has the latest requirement. So if I try to okay, to start now, let me start again. Yeah. So this currently this is like a real world time, right, where you will have the intentional change when you build it and you deploy it. All your changes are available in E2E. When your test case run, it is expected to fail, right? So what will happen? Let me run the test against the current changes. So what will happen is, as expected, this will fail, which is natural. So the normal cases will succeed, but the stocks test cases will fail. So this is where the agentic will come into the picture. Where consider a case like we have a agentic environment, where you have a loop. Whenever there's a failure, where you can trigger your agentic environment to check that, hey, there is a test failure, so that you can have a prompt that, hey, your test cases are failing, try to check it. So your agentic environment will get this data, and then you have your repo, and then your repo has all the context of what is this test and what are all the impacted system within that test. So that I'll try to show it from very local, that consider a case like you have an agent which is up and running in your agentic environment, which has access to all your context and repo, and based on it, if you are providing a prompt that, hey, my tests are failing, check. Consider a case like, so basically this is the prompt, but this is like a very simple prompt. But what happened is your, the framework or your platform will have all the skills and tools. It will try to know how to check the data, right? So consider a case like if it is a context which has to know the future, it will use the GitHub tool to understand the current, requirements. At the same time, it will try to check the, test the validation areas of the repos. It tries to take that and then try to execute them against the platform and see what is the data it is generating it, and then it tries to find it, right? So like this is just a pretty much standard local, because it is running in the local. So it is trying to find the context that basically I need to reserve my stock. But since that is the reason, like what is happening is it was expecting to, since the requirement has changed, I'll try to fix the test. So it will try to fix the test. At the same time, we have the skills included that you have to make sure that your tests are success and running. It's not just not going to create a PR, but at the same time it will run the test case and then see everything is success. So it run the test and everything is success, right? So at the end, what will happen is since you have the code already here, so your agentic environment, you will create this will create your agent will create a PR automatically to your repo, so that as a platform, right, like the time spent from each team to build the test cases is reduced, so that the teams can rely on agents to build and maintain the system. So basically, building the TSLs or building the test cases is completely automated, so that they can look at your context and collect all the APIs, all the domain events from your code base, and whenever you provide the scenarios, it should be able to build the complete test case just from scenarios which humans provide. So this is the quick demo which I want to share here. That this is the workflow. Yeah, going back to this. Yeah. So initially, when we started building this framework, right? So we started with a single team to verify their end-to-end test cases. But over the time, what and all worked for us is we initially started with the DSL-based language, so that they can build their test case in a simple JSON format. But that worked for us simple use cases. But over the time, multiple teams had multiple use cases, multiple complex scenarios to test it. So what we tried is not just like JSON is not going to help. We built it up out of Python, so that the teams can have a Python-based validation as well, so that they can build their logics or the validation in a Python, and they can execute in the system. Second is, as I talked about, having all the tools and the skills out of the box, so that the teams can just use a simple command, so that it can be executed in your agentic environment. Building the test cases, building the context out of the box as a first class support. Third is governance. Like I also talk about this a minute. So basically, when we started, right, so teams do lots and lots of abstraction on their test cases, which is not readable, not executable. Over the time, what will happen is team couldn't able to maintain it. So that is why we had some specific guardrails or governance, so that how you should build as a platform, not like how you should create your test cases, so that you don't deviate a lot, which eventually cause issues where you couldn't able to maintain them. So those are the guardrails, so that it should be readable, reproducible, and maintainable as well. And another thing is, like, we usually run all these tests in CI/CD, and we also have a support to run this like periodically as well, so that whenever there is a upstream or downstream failures, you should be able to know that, hey, there was a upstream failure, your tests are failing, and we have integration with other Slacks that whenever there's a failure, all the notification will be sent to your team, so that whenever there's a failure, we'll get those numbers that, hey, these tests are failing, can you look into it, so that the teams can know that there's upstream failure, so that this can be captured even before your releasing it to prod, and that mean time to detect is also reduced a lot. And last part is this is the programming view, where all the metrics are being collected, and then we have a dashboard which capture all the metrics by systems, so that we can know what are the coverage we have, and what are the by leaders, like what are the coverage we have, and what are the test cases automated, so that we can run programs, and we can we can drive those coverage overall. So this is like an example which this is a dashboard which we built, so that the teams can come and then schedule the test cases and then build out of it. Yeah. So the last part which I want to talk about here is the takeaway. First point is, like, as I talked about here, the teams when we try to try to build the test cases in a simple like existing framework like JUnit or like PyTest and all, what we saw eventually is they are flaky, and due to the eventual consistent nature, like they fail a lot, or they might be flaky. So what teams spend a lot of time is they try to check or they'll try to retry the test again, or they'll try to eventually lose the confidence on those test cases, and eventually they couldn't able to maintain it. But what is also happening is those tests are like going to customers and then causing it. So that's the reason, like, what I want to call out is, like, building a reliable system is need of the hour. Like, customers are using our software, so that their entire day work is based on it, and having an bugs or issues which is missing day to day life is not gonna help customers. So that is the first point. Second is, when we tried initially, like, we tried with all the existing frameworks like PyTest, JUnit and all, but those are flaky, and we couldn't able to build a framework out of it. But once we have a test case which can test their end-to-end flows, that is where we could able to onboard lots and lots of systems, and then we could able to solve these use cases as a platform. So yeah, uh, yeah, that's all from the talk. Yeah, any questions? So basically, these PyTests are there. Like so basically, as I said, it. So we initially started with the JSON-based framework where you'll have steps like what is the given, what is when, what is then, and all, and which we used to run. Second is PyTest, which we added recently, so that the test would be still there, but we'll have a framework which reads your file and then get into context. But we not execute in the PyTest framework. We try to read the file based on the annotation which I showed, right? Like given, when, and then. So we take them as an individual step in your workflow. So first we'll run the given section so that we build the context, and then we'll execute the when, then individually as a workflow one by one, and based on all the data which you are collecting in those steps would be saved. Consider a case like if you have a sleep, or if you have a sleep for like 30 minutes or 1 hour, right? So what we do is we pass the entire test, and then we go to executing other test cases. But when that 1 hour is like completed, right? So what we do is we those test cases again based on the data whatever we collected, and then we execute the next step. So that these tests are not like, even though it looks like a single flow, but it is executed as a workflow in the platform, so that you can run those test cases based on the annotation which you have in the test.
Um, Hello. So my question was this: that how do you take care of duplicate tests or garbage tests that are there? Like sometimes there are tests that are not required, or sometimes agents tend to just create some duplicate tests or unnecessary extra tests.
Yeah, that's the reason I said, right? So it is human cadet. Like basically, we as engineers plus working with your PMs or program like product managers, right? So we have to define like for this future what are the user is going to do the actions, right? So it's not just like hey, look at my code and then try to generate the coverage. This is like looking at your user scenarios, right? So try to create scenarios based on user. That's the reason like main agenda is like don't try to coverage your like code, but try to cover your user action, so that try to think from a customer angle that what does a customer will try to do, right? So as a customer I'll try to create an order, I'll try to make a purchase, right? So these are the use cases where I'll try to buy from a vendor. These are the different aspects of user actions which you can trigger, and there might be a corresponding effect on it, right? Consequently, whenever I make an order, there might be a report changes, right? So whenever I look at a report, the data would be as based on the user action, right? So that is the end-to-end validation which as a team has to do, instead of making sure that try to like try to create a test case just by looking into your code, right? So not like that, mostly from a user action.
Extending to the previous question, and I saw a section in the slide which mentioned that the tests are written in such a way that the impact on the downstream systems are also taken care of. Is it done based on some lineage that we maintain, and is it a static lineage, dynamic lineage? How do we get to know that if some certain test is failing in my job, what downstream jobs will be impacted because of that as well?
Yeah. So basically, like I'm not combining this with the like distributed raising or anything, but this is purely from a customer point. As I said, I consider a case like if customer is creating an order, and there might be a report, like you might be consuming it and then you might be creating a domain event, which your reporting infra might be listening and then creating a report out of it, right? So what the test would be is like start from your customer action, verify your order, and then verify your report is also working as expected. Consider a case like you made a change in the order. What you'll do is you'll have a CI/CD integration, and then you'll run those verification where it will verify your order management service. At the same time, it also verify your downstream, which is your reporting infrastructure. What will happen is since there's a change that it is not supposed to be null, or it is like the schema is changed, then your reporting system might not be able to consume it or process it, right? Then there might be a data would be different, or you might not be able to get the expected results. So then there is expected failure based on a user action, right? Then you could be able to know that hey, based on the current change, there is a downstream expectation is change, like expectation is failing, so it's a downstream failure, so that you can react to it, so that hey, looks like based on the latest change it is failing in the downstream, so that we can take a call. Second is like other existing validations are still part of it, where you'll have a schema validations if you're doing a domain event, right? So consider like you will define a schema that hey, this is how my data is going to be, right? So whenever there's a change, like your schema validation is going to be captured, but what if you have an intentional schema change plus the data change, but your domain changes are not released yet, right? So then what will happen is it will fail the entire flows, right? So that is what like your test case will try to check your downstream as well as part of your flow, and then whenever there's a change, you will get it.
And for the first point where we mentioned that it's based on the user access patterns, is it statically maintained in some metadata from where it is
Yeah, test
refer?
is the like flow is what I'm saying. So basically, your test will have the scenarios that, hey, what are the steps you do? Like this is the step, and this is the flow which is going to impact on multiple things.
So as you talked about, there are like multiple microservices, right? And we are talking about end-to-end test cases. So to run these end-to-end cases, ultimately you need an integration testing environment, right? So did you face any challenges to maintain the sanctity of that integration testing environment, and how did you solve for those?
Yeah, integration tests, like we used to have like similar specifically component test cases which verify your test cases, but this is mostly our end-to-end test cases which we run against both E2E environment and prod environment, so that we also verify, make sure that your test is run, your validation is working on your E2E environment and prod environment. So that consider a case like there was a change in your prod and there's a different config. When you run this test on against your prod environment, you'll also capture those issues as well, right? So we have multiple environment which is E2E and prod, where we'll run all these all these end-to-end test case against this E2E. As similarly, we also have a test case against prod as well, so that we can capture any prod specific config or anything which is there, right? So that is the.
So that is where my question was particularly, let's say for integration testing environment, generally the challenge is how do you make sure that, let's say, C data which you are dependent on to run your test cases, right? How do you keep them up to date with respect to prod data? A lot of configs, lot of static C data is required. How did you solve for that?
Yeah, so that is the, like, maybe I'll go to that part. So basically, whenever you have a scenario, right? So that is the, like, you'll have a certain, as I said, right, so we'll have a governance, right? So that is where, like, we'll make sure that you'll have a clean data, so that whatever the details, either you should be make sure that that data is already part of your company or your like your system, so that when you try to check it, it is always there, so that it is there, or else like you will try to verify your like scenario on a empty company or empty system, so that you'll try to create it and then verify it and then clean up as part of your like entire process, so that either it is should be reproducible, so that you will start from a empty company and then verify it, or empty system and then verify it, or else try to have a non-deletable or non-clearable data and then try to work based on it and then try to clean up your recent changes.
Sure, thank you.